Hi everyone, today we will discuss ionization potential. What is ionization potential? Suppose a neutral atom loses one electron, it will convert into positive ion. So this is first IP. So what happens? This is nucleus. Here electrons are revolving around the nucleus. Nucleus is plus charge, it is minus charge. Nucleus are just keeping the electron in the track. But if you supply some energy from outside, that IP value, then this electron will become free and it will ejected out of the atom and forming the first ion of the atom. If you supply more energy, then one more electron will be ejected out and it will convert into A plus 2. So this is second IP. Surely the first IP will be small, second IP will be more. Why? Because if one electron will escape out, the number of electron will reduce and nucleus charge will be same, so its hold on the electron will be more, and so on. Now we are discussing the trend of IP across period and down the group. So down the group and across period. So across period, left to right and down the group, top to bottom. So key concept in ionization, relative ionization potential value of two different atoms. Bigger the size, smaller the IP. Smaller the IP value. That we will keep in mind. And with the help of this, we can establish the trend. If size will be bigger, smaller the IP. Why? If suppose size is bigger, the nucleus, the outer electron will be far away from the nucleus. So its hold on the electron will be less. So you can easily eject out the electron. But if the atom is small, the outer electron will be nearby the nucleus. So you need more energy to eject out the nucleus out of the atom. So this is the concept why bigger atom has a smaller IP. Now we know the trend. From left to right, atomic size decreases. Atomic size decreases. Why it is decreases? It is because the atomic number increases, nuclear charge increases, but no new shell is added. In a row, cells are, no new cells are added, only electrons are filled in the same cell. So no new cell is added, so radius will not increase and nuclear charge is increasing continuously. So due to higher nuclear charge and non-addition of any new cell, the nucleus pull over electron is more. So it will contract the atom. So atomic size decreases, means left hand side you will get the biggest atom and right hand side you will get the smallest atom. Now this will decide the trend of IP. Bigger size, smaller IP. So bigger size is in left side and smaller size on right side. So IP will follow the reverse order. Means here in lower side, IP value will be small. IP is small. Why IP small? Because atom is, and when you move towards right side, the IP value will be large. Because atom is getting smaller and smaller. So kya conclusion nikla? What is the conclusion? From left to right, across period, IP, यहाँ IP means first IP. IP value increases. This is the concept. Increases as the size decreases. Now come to down the group. So down the group, the atom will have one more shell added. The electron will enter in the new shell. So size will be bigger. So down the group, size increases. And then you see, bigger the size, smaller the IP. Means down the group kya hoga? If size increases, IP decreases. So down the group kya ho jayega? From top to bottom, IP value decreases. So दो concept हुआ. Down the group it is decreases and across the period from left to right it increases. Now, there is no exception down the group. Means down the group it is decreases, means decreases. But in case of period from left to right, there are some exceptions in between. Means it will not continuously decreases. I am telling it is decreases. Means it should continuously decreases from left to right. No. In between, some exceptions may arises. What are those exceptions? So these exceptions are two types of exceptions. Fully filled s orbital and half filled p orbital. Fully filled s orbital means what? The outer electron fill up, enters the s orbital and completely fills up. Half filled p orbital means what? The outer electron, last electron enters and half filled, this is the last, and half filled the p orbital. This is the last electron, here it is entering and making p orbital half filled. If these two cases are there for the element, then they show the abnormal behavior against the trend. So let us consider with an example. Now you see, this is the summary. Across period, IP increases, down the group IP decreases as per normal trend. But I have told across the period some exceptions are there, that I am showing with example of period 2 elements. So in period 2 elements, across the period from left to right, lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. These are the elements. You see the electronic configuration. First you understand, as per normal trend, what should happen? IP value should increases. Means lithium should be least, then beryllium, then boron, then carbon, then nitrogen, then oxygen and then fluorine. This is the trend it should follow. But here, if you carefully observe the electronic configuration, so in case of beryllium and in case of nitrogen, you observe here last electron, it is filling 2s2, means fully filled s orbital. Last electron is making fully filled s orbital. It is a stable configuration. Means what? It will supersede its next member, next family member. Means what? From next family member it will interchange. Means order will be reversed. Boron will come first and beryllium will go ahead. First interchange happens here. Then you come here, normal trend. Now come nitrogen. Nitrogen again, last electron is entering in p orbital and making it 2p3, means half filled p orbital. It means extra stability nitrogen is getting. So again it will violate the trend, normal trend of IP. In normal trend, n should be less than O, but since n has half filled p orbital, n will supersede its next family member. So again here order will be reversed. N lies above the O. Like here B lies above boron. Correct? And rest members will lie like that. And fluorine. Now you apply the same symbol. This is the order. If you see the exact practical values, so this is kilojoule per mole. The exact measured values are 500 kilojoule per mole IP value for lithium, then 800 for boron, then 900 for beryllium, then for carbon it is 1086, then for oxygen it is 1314, for nitrogen it is 1403, and for fluorine it is 1681. And last member is neon. So this is noble gas. So of course it will, complete octet is there. It must have highest IP value and it is 2081. 2081. Since it is noble gas, octet is completed. So half filled S filled का कोई मतलब नहीं है. It must have highest IP. Now the IP value are exactly matching what we have justified with fully filled s orbital and half filled p orbital. So this is the periodic trend of IP value across the period from left to right and down the group from top to bottom. If you like this video, Please give a like button and please subscribe my channel so that I can also be motivated to put some more videos that may be helpful for you. Thank you.